Hi and welcome to section 2, drawing your first plots and customizing them. In this section we'll start by drawing simple plots and cover some customization. Now we move on to the first video of this section that deals with defining plot types and drawing sine and cosine plots. In this video we're going to take a look at creating basic plots in Matplotlib, comparing various kinds of plots and plotting sine and cosine functions. In this video we'll present different basic plots and what they're used for. Most of the plots described here are used daily, and some of them present the basis for understanding more advanced concepts in data visualization. Then we'll draw sine and cosine plots to understand basics of plotting mathematical functions. We start with some common charts from the matplotlib.pyplot library with just sample datasets. Starting with basic charting, we lay down foundations of the upcoming videos. Let's create a simple plot in IPython. IPython is great because it allows us to interactively change plots and see the results immediately. Here are some steps we need to follow. Start IPython by typing IPython at the command prompt. Here you can see I'm using IPython version 5.1.0. I've also imported pylab manually for obtaining the output. Next, import the necessary functions. This is the matplotlib function. Then we type the matplotlib plot code. The plot would open a new window like this. The basic plot in matplotlib contains certain elements. 1. The x and y axes. These are both the horizontal and vertical axes. 2. X and y tickers. These are little tickers denoting the segments of axis. These can be major and minor tickers. This is X ticker and this is Y ticker. 3. X and Y tick labels. These represent values on a particular axis. Here 2.5 is Y tick label and 2 is X tick label. 4. Plotting area. This is where the actual plots are drawn. You'll notice that the values we provided to plot are Y-axis values. Plot provides default axes for the X-axis. They are linear values from 0 to 7, the number of Y values minus 1. Now try adding values for the X-axis as first argument to the plot function. This will update the plot to look like this. We see here how matplotlib expands the Y-axis to accommodate the new value range and automatically changes colour of the second plot line to enable us to distinguish the new plot. Here you can see the green line, which is the new plot, unless we turn off the hold property by calling hold false. All subsequent plots will draw over the same axis. This is the default behaviour in pylab mode in IPython, while in regular Python scripts hold is off by default. Let's take a look at some more common plots and compare them over the same dataset. This is the code. You type this code in IPython or run it from a separate Python script. I'm running it separately. With figure, we create a new figure. If we supply a string argument such as sample charts, it will be the backend title of a window. If we call the figure function with the same parameter, that can also be a number, we'll make the corresponding figure active and all the plotting will be performed on that figure. Next, we divide the figure into a 2x3 grid using a subplot call. We could call this subplot 2, 3, 1, where the first parameter, that is 2, is the number of rows, the second parameter, 3, is the number of columns, and the third parameter, 1, represents the plot number. We continue and create a common charting type using simple calls to create vertical bar charts and horizontal bars. In second subplot, we use bar function with parameter xy, which is used for creating vertical bars. In the third subplot, we use bar h function with the same parameters for creating horizontal bars. For stacked bar charts, we need to tie two bar chart calls together. We do that by connecting the second bar chart with the previous using the parameter bottom equals y. Box plots are created using boxplot call, where box extends from lower to upper quartiles with the line at the median value. We'll return to box plots shortly. We finally create a scatter plot to give you an idea of point-based dataset. This is probably more appropriately used when we have thousands of data points in a dataset. But here we wanted to illustrate the difference in representations of the same dataset. We've used scatter function in which parameter is x, y. Now let's run the code. Type the file name. This is how it turns out into graphs. Here's the first subplot. This is the second one, which has vertical bars. Third one has horizontal bars. Fourth is stacked bar chart, where we've combined two bar charts. Fifth is the box plot. And the last one is the scatter plot. Cool, isn't it? Now let's learn more about the box plot. These are the characteristics of the plot. Box, a rectangle that covers the interquartile range. Median, this is presented as a line inside each box. Whiskers, these are vertical lines extending to the most extreme values, excluding outliers. Flyers, these are points beyond the whiskers, which are considered outliers. To illustrate this behavior, we will demonstrate plotting the same dataset in a box plot and a histogram. This is the code. Let's run the code and compare. Here it is. In this output, we can observe a difference in representation of the same dataset in two different charts. The box plot points towards the 5 mentioned statistical values, while histogram displays the grouping of the dataset in a given range. Now let's go over the basics of plotting mathematical functions and things that are related to math graphs, such as writing Greek symbols in labels and on curves. The most common graph we will use is the line plot command, which draws the given x-y coordinates on a figure plot. Let's take a look at the code. We start with computing sine and cosine functions over the same linear interval from -π to +π with 256 points in between, and we plot the values for sin x and cos x over the same plot. Upon running the code, we get this graph. Following this simple plot, we can customize more to give more information and be more precise about axis and boundaries. This is the code. Here we define plot title and set x and y limits. We also format ticks at specific values. That should give us a slightly nicer graph. There it is. You can see the customizations we added. Awesome. Now, there's an important thing we need to see. We used expressions such as sine or pi to write letters of the Greek alphabet in figures. This is LaTeX syntax, which we'll explore further in the upcoming sections. Here we just illustrated how easy it is to make your math charts more readable for certain audiences. So that's about it for this video. In this video we went through various plot types and plotted sine and cosine functions. Cool. In the next video we'll learn about defining axis lengths and limits.